Hello guys, this is Prime Concept. We are still looking at the concept of eye defect. Now in our previous video, we started by explaining one of the eye defect, which is what? The short-sightedness. In this video, we want to look at another eye defect, which is long-sightedness. Long-sightedness, which can also be called what? Hypermetropia. Hypermetropia, that is the long sightedness. At this point, if you have been watching my videos and you are yet to subscribe, please do well to hit the subscribe button, comment on this video, like, and always share with your friends. Now, what is long sightedness? Very quickly, a long sighted person is someone that can see things that are very far, but when those things are brought close, they can no longer see them clearly. So when you see a long-sighted student in your class, you would notice that long-sighted students, they don't like sitting in front, because when they sit in front of the class, they won't see those things on the board very clearly, because those things eventually are too close for them. So they want to see clearly. You would see them, they like sitting at the back, and you'll be asking them, why would you want to sit at the back when we have space in front? Is because when they sit in front, they don't see things that are close. So long-sightedness is a condition whereby near objects cannot be clearly seen by the eyes, but distant objects can be what? Seen clearly by the eyes. That is long-sightedness, right? Now, what is the cause for long-sightedness? Long-sightedness happens because the eyeball is usually too short or too small. The eyeball is too small, and then the focal length of the eye lens is actually very long. So you would now notice that if the focal length is long and the eyeball is small, you notice that the focal length would be somewhere at the back of the eyes, so that when that person is trying to view something that is close, the image of that thing, instead of being formed on the retina, would now be formed at the back of the retina where the focal point actually lies, right? So that is the condition, the eyeball being too short and then the focal length of the eye lens being too what? Long. So that is what causes long sightedness. Now let's look at a diagram that will illustrate how the image is formed. So this is the eye lens, this is the eyeball. Now, if for a long-sighted person, when an object is being viewed by this person, when the rays enters the eyes, because the eyeball is too short, so let me make this short so that you would agree with me, like this. Because the eyeball is too short and the focal point is somewhere behind, so when it enters, when rays enter your lens, they would move so that they would converge. You can see where they are converging at a point outside the retina, or behind the retina actually. So since this point of convergence is not on the retina, it means that when this person is trying to view something that is close to his eyes, not very far, that person will be seeing them blurred. It won't be clear to that person. Then you say the person is long-sighted, right? Now, if we want to correct this defect, what do? We're going to use, to correct long-sightedness, we use, it is long-sightedness, so pardon my mistake there. Now you use the convex or converging lens to correct this kind of defect. So what do? We give that person an eyeglass, right? That is made from a convex lens. So this is the person's eyeglass. That is a convex lens. So that when light comes in from a far place, and it comes in, enters parallel rays, they would now converge, because this lens is a converging lens, so it will converge it. Now when it hits your eye lens again, which is also a convex lens, it will still help to converge it even further, so that it will now be converged somewhere at the retina. So why does this really work? Because they would have calculated the focal length of your eyes, so that they would know the focal length and then the distance from your eye lens to your retina can be estimated, right? So when they estimate that, they can use that to determine the focal length of a lens they are going to give you. Now, while you are mentioning that this problem can be solved using the convex lens, you should know that it is not convex lens for of all focal lengths that a particular person can use. So the particular convex lens a particular person should use is a convex lens that corresponds to the focal length of his eyes, so that he can see clearly, right? So it means if you have two persons that are long-sighted, that have long-sightedness, you have two different persons. If you produce glass, those two different persons cannot use the same glass except their focal length corresponds. So in as much as we are using the convex lens, is not of the same focal length for everybody, right? So you should take note of that point. So what it means is that to correct long-sightedness, we use the convex or converging lens. So I believe this concept is clear to you. Just to highlight this, a long-sighted person can see something far but cannot see something close. That's a long-sighted person. And it is as a result of the eyeball being too small, too short, and then the focal length of the eye lens being too what? Long. So that is the reason for that. How do you correct it? You use the convex lens. Now, quickly, I would mention in this video the other two bonus eye defects. So other eye defects you can have would include presbyopia. So this is another eye defect. This eye defect usually occurs with age. So when people are aging, remember I mentioned that the part of the eyes that is responsible for adjusting the eye's focal length is the ciliary muscle. So that when people get old, the ciliary muscle becomes weak. It's no longer elastic, because the ciliary muscle is elastic in nature. It can expand, it can contrast. So, but with age, with time, the muscle becomes weak. It can no longer expand freely. It loses its elasticity, right? As a result of that, something that is far or even near can no longer be clearly seen by somebody that has presbyopia, right? So if it is far, you can't see it clearly. You would need glasses to see it. If it is close, you still need glasses to see very clearly. So this kind of defect, you would need a combination of both convex and your concave lens, so that you can correct both the defect of long-sightedness and the defect of what? Short-sightedness. So to correct presbyopia, we use the bifocal lens, a lens that has different focal lengths, to correct long-sightedness and short-sightedness. And then the fourth one I want to mention here is what you know as astigmatism. Astigmatism is simply as a result, it still happens with age. So these two defects are majorly predominant with old people, right? So astigmatism is as a result of the unsymmetry of the cornea. Remember we mentioned the cornea as a layer of the eyes, right? That actually still gives shape. It's still part of the part that gives shape to your eyeball. So astigmatism is as a result of the cornea having different shapes at different points, because the cornea expands up to the back of your eyes. So, but the shape of the cornea is no longer symmetric. That is to say, the shape at this point is not the same shape at this point. It's not the same shape. So it has different shapes. Thereby, when somebody that has astigmatism is trying to look at an object, it will form, instead of forming a single image, it will form multiple image. That is when the person begins to tell you that, complain that I'm seeing this thing too. When you look at something, you see it double. That is actually astigmatism. So to correct astigmatism, you use what kind of lens? You use the cylindrical lens to correct astigmatism, and you use the bifocal lens to correct what? Presbyopia. So I believe this concept of eye defect is clear to you. If you have enjoyed this video, please do well to hit the subscribe button, and under the comment section tell me that you enjoyed this video, and like this video and share with 10 of your friends. Tell them this is prime concept. Thanks for watching.